Okay, now that we've talked about inequalities, how to graph and solve them, that leads us to compound inequalities. Let's take a look. We have two types of compound inequalities. They're formed by joining two inequalities together, but we use the word and then we can use the word or. If it's an intersection, we use the word and. When we graph that, it shows the numbers solutions for both, and you'll see that they overlap. A union uses the word or, and it shows solutions of either inequality. So the word and the word or will help us to understand what we are graphing. So when it looks like this is an intersection. So it's the word and. The way we read this is a number is greater than 2 and less than or equal to 5. So think about what that right there is saying to our brain. It's saying that our value of x is somewhere between those two. So you might be already thinking about what our graph would look like. Here's how we graph those. First, I like to rewrite this. If we pull apart the original problem, we have 2 is less than x. But it's also saying x is greater than 2. So that helps us with our graph because remember, we would put an open circle and shade to the right. Then we have x is less than or equal to 5. My x is on the left-hand side, so I can use my graphing trick. This time it's a closed circle, but I shade to the left. So when we graph compound inequalities, we graph them all on the same graph. I would first place my 2 and then my 5. Notice there is a point where those two overlap. That alone is the solution. I would erase the two sides right there. What you see here is the solution to this. This is how we graph it. Because like we said, it's anything between 2 and 5, and it can include 5. Let's go look at what a union graph would look like. Remember, unions are an or. So this is read, a number is less than 2 or greater than or equal to 5. So I would first have to take my first part and graph that inequality. This time it's shading to the left. Then I graph x is greater than or equal to 5, and my graph shades to the right. No matter what, whether it's an intersection or a union, we place it on the same graph. So I would first draw 2 is greater than, and then I would graph 5. So notice what's happening here. My two graphs are going in different directions. That right there, that is the solution here. An or, it's either one or the other. That's why those words and the word or help us to understand what our graph should look like. So let's practice determining whether it's a union or an intersection. Remember, union is the word or, intersection is the word and. That helps us also write our inequalities. Well, graph 1 would be an or. If you notice, we have an open circle at -2. So I would use the symbol less than, because everything less than -2 is shaded. Then it's or x is, notice the open circle at 5, okay, greater than. It's going to be one or the other, not both. Graph 2 is an and. Look how it's shading both things, okay? So that means I have a closed circle at -2. So just first write this inequality for this one. So that's greater than or equal to. Then I would have an open circle at 5, so that's less than 5. What I do is I write both. What this is saying, x is greater than or equal to -2, and x is less than 5. So we can write it this way with the word and, or I can put those two inequalities together and write it this way. So it's super important, and I know we don't like saying this, but remember in elementary school, the alligator eats the bigger one. Well, when you rewrite this, the alligator still needs to eat what it was originally eating. So we need to be sure that when you are writing both of these, that you are using the word or and the word and. If you don't put that in between, it will be marked wrong. So pause the video. Okay, try this on your own. So you should know that graph 3 is an or. We have a closed dot at -2, and it's shaded to the left, so it's less than or equal to. Okay, or, notice I typed the word or. Then we have an open at 5, and it's shaded to the right, so that it's greater than. That right there, that's your answer. Graph 4 was an and. Okay, and notice it's in between those 2 points. But it's a closed circle here at -2. So that is greater than or equal to. And then, and notice I said and, then I have a closed circle at 5, and then it was shaded to the left. Okay, if you want to put those two together, you should have gotten -2 is less than or equal to x, which is less than or equal to 5. Okay? So just like we solved inequalities, we can solve a compound inequality. When we have an or statement, we basically have 2 separate inequalities to solve. We don't change anything about that. So what I'm going to do is I'm going to solve each one separately, but I'm going to graph them on the same number line. So 3x plus 2, I would subtract 2 to get 3x is less than -9. I would divide both sides by 3, so x is less than -3. When I come over and I solve my other one, I subtract 5 from both sides to get -4x is less than -4. I divide both sides by a negative. Therefore, my inequality symbol has to switch directions, and I got a 1. Now I graph them on the same number line. I graph one at a time. Okay, it's an or statement. I'm going to put an open circle at -3, shade to the left, open circle at 1, shade to the right. That would be my solution. I have to show both inequalities and their graphs because it is a compound. So what now? Take a look at this one. What is this? Is this a union? Is this an intersection? You should start recognizing my variables in between. Okay, this is an intersection. It's an and. What I would need to do is to write 2 separate. Rewrite this using the word and then solve. Meaning, cover that one inequality. Look, I have an inequality here. -8 is less than or equal to -2x plus 12. Okay, cover this other side. There's another inequality. -2x plus 12 is less than 10. Now I have the ability to solve each one separately. So I subtract 12 from both sides to get -20 is less than or equal to -2x. divide by negative. You hear what I just said? I'm dividing by a negative. So I get a positive 10, but my symbol needs to switch. Therefore, 10 is greater than or equal to x. That's that one. And I have to go solve my other one. Subtract 12 from both sides. Negative 2x is less than negative 2. Divide by a negative. So x is greater than 1. Now, I'm going to place those both on a number line. I have 10, and I'm going to shade to the left because 10 was greater than all my values. Then I have 1, but x was greater than 1. Where those two merge in the middle, that is my solution right there. I would erase anything on each side. And I have now solved this compound inequality. Okay, here's two problems. You're going to answer these on your own. We will be checking to see that the work is done. We are checking these two answers specifically to see that you have the right work and that you've written a summary.